conditional probability is given events A and B. Conditional probability is the probability that event B is occurring, knowing that event A has already occurred. Okay. Conditional probability is events A and B. It's the probability that event B occurring, knowing that event A has already happened. Okay. The notation that's used for that is probability with parentheses, like it's been in the past, but it's B and then a straight up and down bar, A. Okay. The way you read that is the probability of B given A. That's the way it's read in most contexts. Probability of B given A. What that means is A's already happened. We want to find the probability of B happening out of that. The formula for probability or conditional probability, B given A, is it's the probability of A and B divided by the probability of A. Okay. That probability of A and B, that goes back to what we talked about yesterday. We have to take into account, is it an independent event, dependent event, when we find this probability up here. And then we're going to divide that, however how we do that, we're going to divide that by the probability of A happening. That's the way we're going to have to do that. All right. Just takes a little practice. It's not really hard. It's got a little more of a formula than what we did, and it's building on what we've already done. Okay. So some examples here. So Mitchell drew a card from a standard deck of playing cards. Remember we talked about the standard deck. What's the probability that he drew a queen given that the card was red? Okay. So we're going to make the assumption that it's with replacement. Okay. So what's the probability of this? Drew a queen given that the card was red. So what this is probability of a queen given that we drew a red card. Okay. So what's the probability? So the way we're going to do that is probability of red and a queen divided by probability of red. Right? That's what we're going to do. So we want to find the probability. What's the probability of drawing a red card? Yeah, 26 out of 52, which ends up being 1/2. That's exactly right. And then the probability of it being a queen would be 4, because there's 4 suits. There's 4 queens in a deck out of 52, right? And then the probability of it being a red card, we've already got this one right here. So we simplify that. These cancel each other out. Just 4 out of 52. I ran out of room. Grab that. Shrink it. Is it always going to be that same fraction there? Not always. Those are independent events, so that changes things. It's dependent events.
I need the following students to the library at this time: Emily Marks, Brooklyn Sunday, Jessica Sagely, Michael Weaver, Tamara Jackson, Selena Breimer, and Carrington Knight. To the library.
All right. Now, number 2 says a number from 1 to 100 is randomly selected. What's the probability that it's a perfect square, given that it's an odd number? Okay. So, what's the probability of it being an odd number? 50 out of 100, right? What's the probability of it being a perfect square? So how many perfect squares are there from 1 to 100? So let's count. You got 4, 9, 16, 25, 36, 49, 64, 81, and 100. There are 9. Well, what about 1? We forgot 1, right? 1's the square number 2, right? So there's 10. That's the one we forget about. And then divided by 50 out of 100. Again, independent events. Cancels that out. 10 out of 100. 1/10. Not terrible here. And again, I'm using this formula because when we get something that's a little bit more difficult that you need that formula for, you're going to have to apply. All right. There are 62 people that take a yoga class, 48 people that take a spinning class at the gym, 15 take yoga and spinning, or also take spinning. If a person from these groups is selected at random, find the probability that he or she takes yoga if you know that they take the spinning class. So, probability of yoga given spinning. All right. So, how many people are there altogether? $62 people take yoga, 48 people take the spinning class, 15 people take yoga and spinning. So, one of the best ways to figure out how many total people there are here, y'all remember Venn diagrams, ever doing those 2 circle pictures like that? Y'all remember doing those? They've been a while since you did. Yeah, it is getting, there's a lot of stuff going on. So, if there are 15 people that take both, where's that go in a Venn diagram? In the middle. So there's 15 there. That 15 is in both circles, right? So let's say this circle's yoga and this circle's spinning. All right. So 48 people take the spinning class. So if there's 15 that take both, how many, if there's 62 that take yoga, how many are left that only take yoga? We've already got 15 of those people accounted for because they're in the middle. So we take 62 minus 15, 47. So there's 47 people in the yoga class. And then how many people, 15 remember already taken, they take both. So we've already got 15 of these 48 taken care of. So how many people just take spin? All right, now that tells us the total number of people that go to this gym will be 47 plus 15 plus 33. Yeah, all right, so that tells us that. Now, because we've made this Venn diagram and the nature of this problem, I think it's easier to think about this in terms of saying, okay, how many people, if you know they take the spinning class, how many people does that mean we're looking at? We've sorted the group, and we've got the people that take spinning class here, and then everybody else. How many people take spinning class? 48. It told us that, right? then what's the probability of picking somebody that takes yoga if we're only looking at that 48 people? Why 15 out of 48? That's right. 15 people take both. So when we got this, we've narrowed our group down. We segregated the congregation. Okay. I don't know if y'all's church like this. There's people that sit on the left side of the church, and there's people that sit on the right side of the church. Church I go to, we got 3 sections. So we got some people that sit in the middle. And I don't know if that's biblical or not, but that's the way our church is. But you got people. So when you separate it and you say the people that are on the right side and you're picking from that group, that's what we're doing here. We're taking this and we're separating and saying, okay, we're looking at only the people that take spinning class. And then we're saying finding our probability from that. Okay. So we've separated this to say, okay, we're only looking at this 48 people that take spinning class that are in the right side circle for spinning. And then we're looking to say, well, what's the probability of picking out of those people, picking somebody that takes yoga class? And that's where Calvin got the 15 from. Okay, 15 people are all that's in there that also take yoga. So that's a 15 out of 48. We can obviously reduce that because 3 goes into both of them. 5, 16. So here's a good classroom example that we could do with our group if we wanted to. There's 30 students in the class. 13 are athletes, 9 are in the band. 3 of the athletes are also in band. That's tough to do here, just because of the way the schedule works and you can't get enough classes in if you're in both, okay? So 3 athletes are also in the band. If one student is chosen at random, find the probability that the student is in band if we know they're not an athlete. So this one changes a little bit. So this one would be a good one to try to do the Venn diagram idea again. So we got band and athletes. Not mean to make the athletic circle bigger. Don't read into that, please. Meant to make them the same size. Okay, so how many people go in the middle? 3. How many people are athletes total? 13. So how many are just in this part of this circle? 10. How many are band members? There are 9 total. 6 would be out here, right? Where's the rest of them go? They're not in any of those, right? So they're outside of that. How many people are not in those? 11. There are 11 people that are not athletes or not band members. Okay. Yes, sir.
You're on 6 in band.
No, I didn't.
Oh, wait.
That's on purpose. Because we already had 3. So I had 6 left over that were just band members that didn't play a sport too. All right. Now, from here, we want to find the probability that a student's in band if we know they're not an athlete. Okay? Not an athlete. So, what people are excluded from this problem? That's an easier question to answer. That anybody that's in the athletic circle, which is how many people? 13. So that means we're picking from how many people? There's only 17 people that we're picking from now. Okay, because we've taken anybody that plays sport and threw them out. Or set them in the hall. We can throw them out of school. Not want to, but we couldn't. So 13 people are out. That leaves us 17 total. How many people are in the band? 6. 6 out of 17. When you start dealing with these problems like this, sometimes that Venn diagram is very helpful in being able to deconstruct the problem. And we don't do a lot of those anymore in math classes, just as we spend so much time doing algebra that you don't spend a lot of time doing that. But it's very, very helpful. Okay? All right. Two-way tables. Fun times here. So a table that records data that pertains to two different categories, that's a two-way table. That's the definition of that. Here, this table shows the results from a poll of 50 randomly selected students. They were asked whether they prefer to watch hockey or football, and then we want to find each probability. So we got first row is people that prefer football, the boys and the girls. Second row is prefer hockey, boys and girls. Okay. First column are the boys. Second column are the girls. So if they ask anything about given boys or given girls, you're thinking column here. Okay. Now, part A says they prefer watching football given that they're a girl. That's what that notation says. So we're only looking at the column that has girls in it. Okay. So how many people or how many girls are in that column? Check again. 22. All right. 6 plus 16 is 22. So there's only 22 total. How many of those 22 prefer football? 6. So the two-way table is kind of like a Venn diagram. It's representing more than one category, where the Venn diagram's a little, it's one situation. All right. Part B there says probability of picking a boy given that they like hockey. Okay, so what part of that table are we looking at? All right. So what part of that chart are we looking at? Are we looking at the boy column? The hockey row, right? Because it says given hockey. So hockey is represented on a row. So we're looking at these. So how many people are on that row? 26. Probability of picking a boy out of that would be 10 out of 26, which we can reduce, right? 5 out of 13. The conditional probability, you've got to look at narrow your field down a little bit. And they give you all that information out of that. First couple of problems, they didn't give us all that information. We had to think about the deck of cards. All right, number 5. Says the table shows the results of a poll in 150 randomly selected middle school students who were asked if they take French or Spanish. Sounds like our school. 150 randomly selected middle school students who were asked if they would take French or Spanish. So we're going to answer these parts over here about that. Okay. Probability of a 7th grader picking a 7th grader who takes French. Okay. The probability of picking a 7th grader who takes French. All right. How many French are in the 7th grade? 7th grade, how many? 25 people take French. Okay. How many people are there total? A 7th grader who takes French. So we're picking from this whole group. We didn't get a given. Just notice the difference in the way A is written and the way B is written. Don't have that bar in there. So they're just saying, out of this group, what's the probability of picking a 7th grader who takes French? 25 out of how many are in there together? 150 total. Reduce that. 25 goes into itself and into 150. $1.50 has 6 quarters in it. Now, B part is we're picking an 8th grader given that they take Spanish. So what part of that chart are we looking at? 8th graders that take Spanish. So how many 8th graders take Spanish? 33. What's our bottom number? Where's 71 coming from? No. You add up the Spanish because what's the given that they take Spanish? So we want to add up the Spanish here. If it were just if it just said what's probability of picking someone who takes Spanish given that they're in 8th grade, then you do add up the 8th grades. But here we're taking 8th graders given that they take Spanish. We know they're in Spanish class. So 33 out of 45, 68. And that doesn't reduce. 33 and 68 don't have anything in common. C part. Probability that they take French given that they're in the 6th grade. What's our probability there? Say that again. Where are you getting those numbers? What the problem asks for? 6th grade. So how many should it be on top? 19, right? Out of how many? I heard two different answers. Why 42? Explain why. Yeah, because we're taking a given at 6th grader, so we're only dealing with 6th grade. So that's where we're getting that 42 from. Good job. So, all right. Part D says probability of picking a 7th grader given that they take French. So this is very similar to B part. So what part of the chart are we looking at? The French column, right? Because it's given that they take French. So we know it's out of this. And how many 7th graders are there? 25 in that column. So 25 out of a total of 82. And that doesn't reduce. 25 and 82 don't have anything common. Don't overthink this, but don't get in too big of a hurry either, as you make mistakes either way. All right. Number 6, got another table and some probabilities to find. It says the table shows the results of a poll randomly selected juniors and seniors who were asked if they attended prom. We can change that to snowball if we want to. That's this weekend, right? Is that right? Anybody ever been to Hope Vineyards? It's a beautiful place. Y'all gonna like it. It's nice. Really nice place. All right. Table show. So we got juniors that said yes, and seniors that said yes, and then the no's for both of those. Okay. Probability of a junior that did not attend prom. Okay. Probability of a junior that did not attend prom. So juniors that did not attend would be 56 out of how many? 200. Okay. Wait, oh, that'll reduce one. 56 and 200. 7 and 25. Good. I was trying to do my division by 8 there. 200 is a little more difficult than 56 was. All right. B part. What's that asking for? 8. Thank you very much. So did not attend prom given that they're a senior. So which column or row are we looking at? Seniors column, and did not attend the prom. So top number is going to be 19. Bottom number is going to be 116. And 19's prime, and it doesn't go into 116. So it won't reduce. Okay. C part. What are we looking for? So juniors, given that they did what? Attended prom. So what part of the chart are we looking at? The yes row, the junior column, the no row, the senior column. Which one? Or which ones? The yes row, and then the juniors there. Okay, so top number is 28, bottom number, how much? 125. 28, yeah, you add up all the people that went, because it says, given that they attended prom, so we're only looking at these people and picking the juniors out of that. Okay. Does that reduce? No, it doesn't. Okay. All right. Frequencies. A couple of definitions there. Joint relative frequencies are the values in each category divided by the total number of values. And then the marginal relative frequencies are found by totaling each row and column. So we're just finding some frequencies here. In statistics, we make frequency tables, and they're useful in analyzing data and stuff. So this is kind of a precursor to that sort of thing. Is developing these frequencies is what we're kind of trying to get you ready for. All right. So table below shows the number of first class and coach class passengers on a plane who checked one bag, two bags, or no bags. Find the joint relative and marginal relative frequencies. Then find each probability. Okay. All right. So how many? Let's get something first. To find the any of those frequencies, we need the total number of values, right? So let's total up all of this. So 16 plus 52 plus 12 plus 60 plus 2 plus 18. Somebody add those all up for us. It'd be 160. So we know that that's 160 total. That's helpful. Now, what do we know about, let's see, if we're going to do the marginal relative frequencies, totaling each row or column, we need the totals for rows and columns here, right? Or, well, what's the probability of someone in first class? So let's get those probabilities for this chart over here. Since we got the total, we can get some probabilities. In first class, what's the probability somebody checked two bags? Probability of picking somebody that checked two bags in first class. Not a given, no givens in this. 16 out of 160, right? So 1/10. I'm gonna write it as a decimal because the chart's kind of small, and we're gonna end up with some decimal stuff here. Frequencies are generally written in decimal form anyway. 0.1. Same idea. Let's just go down that first class since we're already there. 12 out of 160. What is it as a decimal? 12 divided by 160. 0.075. And no bags would be 2 out of 160. Okay. And then our chart asks us to total that up. So add up these three. Yeah. Yeah, just add them. Since they're already stacked up. All right, now let's do the same thing for the coach class. 52 out of 160. What is it? Decimal. Good. And then 60 out of 160. It would be close. Same thing. And then 18 out of 160. Be a little bit more than 2 bags in first class. 1, 2, 5. And then total those up in that column. So 5, 5, 5. 8, 1, 9, 10, 11, 12, 9. Is that right? All right, and then total across. Okay, if we total across, totaling across, this is going to be our marginal relative frequency. So add these two together to get this total. It'll be 0.425, right? That's easy to do. Add across on the one bag row. 5 is 10. That'd be 8 and 7 is 15. So 0.45. Add across here. 125, is that right? 0.0125. 0. I can't type things in my calculator. 125. Now here's the cool thing. What happens when you add these two together? What happens when you add all three of these together? It should. Because what are all of our probabilities supposed to add to? We learned this the other day. All your probabilities should add to be 1, right? So if that's kind of the, did I do this right? If it doesn't add up to be 1 this way and this way, something's wrong. Out of that, okay? All right. So here we get a probability. Here's what we're getting from this chart, okay? What's the probability of picking 2 bags? Somebody that checked 2 bags. Okay. What's the probability of somebody that checked 1 bag? Okay. What's the probability of picking somebody that checked no bags? Okay. What's the probability of getting somebody that was from first class? Right. What's the probability of picking somebody from coach class? Right there. We get all of those things all in a nice chart, and it's easy to find. All right, so let's get some answers here. Probability of a coach class passenger that did not check any bags. Coach class passenger, no bags. Where's that at in our chart? Coach class column, no bags. B part, a first class passenger that checked at least 1 bag. Ooh, at least. That means they could have checked 1 or at least or 2, 1 or 2, okay? At least you're going to go smaller and bigger. At most you would go the other direction, okay? So the difference in those words there. So at least 1 bag, you get 0.075 plus 0.1. Okay. C part says coach class given that they checked 1 bag. Okay. A coach class passenger, given that they checked one bag. 0.375 is the probability of a coach class passenger, right? Given that they checked one bag, what's the probability of picking one bag? Right there, 0.45. If we divide those two, that's going to get us our probability. So I don't do that in my head. Probably take me a minute. 0.83 repeating. Use that bar notation we used when we were kids. You could have gotten the same answer from the original chart with the numbers, but you would have to do more totaling and all that stuff out of that. So given that they checked one bag, you go here. So 60 out of 72. Should be the same thing, I believe. Yeah. All right. Check two bags, given that they're first class. How many people, or probability of checking or being in first class is 0.1875. So that's the bottom number. The top number would be that you're checking two bags and you're in that class. That'd be 0.1. So 0.1 divided by 0.1875. 0.53 repeating. All right. Oh, do a little thinking. With this, there's 14 problems, but there's subparts on the back. Yeah, normal schedule today, so we'll go to second block today. Unless they make an announcement and say don't. Very likely because I told you that it worked.